Hello and welcome to today's episode of Rawkode Live. I am your host, Rawkode. Today, we're going to be taking a look at one of my favorite tools for managing Kubernetes manifests. That is Kapitan. It helps reduce the complexity or manage the complexity of your Kubernetes, Terraform, and other deployments and configurations. To do that and to join me today, I have Alessandro and Ricardo from the Kapitan team. Hello.
Hi. Hi. Hi, David. Thank you for having us. Yeah.
No, it's my pleasure. I really do mean it. I say this is one of my favorite tools. So I'm really glad that I'm joined by both of you today and we can share that and show that to everyone that is watching. Shall we start briefly then with some introductions? We'll start with Alessandro, since you're first on the screen, and then we'll move down to Ricardo.
Yeah, so my name is Alessandro De Maria. I'm head of SRE at Synthace, a company that deals with automation, but in biology. So it's quite a relative kind of a field, in this case. And I used to work at DeepMind before, so that's where I met Ricardo, and we got together to work on Kapitan. So at the moment, it's I think 3 or 4 years that we've open sourced it, and I think this year we've seen much more interest, and we want to take advantage of as much as we can of you and everybody else in the community to see if we can make it more popular, give it better opportunity. That's for me.
Cool. Hi, I'm Ricardo. I am currently a software engineer at Google. I think it needs no introductions. More specifically at Google Health. And before that, I was also at DeepMind, as Alessandro said. And we were running a team of SRE there, and that's when we, had the idea to create something like Kapitan. And thank you for having me here.
Awesome, thank you very much. All right, so why don't we start then, and just tell people what Kapitan is? Do you want to use the slides for that, or do you want to talk about it first?
Yeah, I think the slides is a good way. We try to. I think let me make sure that they are open. Yes. So we try to explain it, and pretty much every time it comes out in a different, from a different point of view. I don't know if the slides are already visible. Yeah.
They are. Please. Yeah.
Yes. Perfect. Yeah. So Kapitan is a tool again that we created in a DeepMind at the time where there were fewer opportunities, fewer other tools. I think Helm was already out there, but we were looking for something slightly different, especially because we had a very kind of particular setup with DeepMind Health, where we were working on loads of components that we were doing ourselves. So I'll start with this kind of slide just to explain a little bit what led us to work with to work on Kapitan. With Helm, with Kubernetes, we realized at the beginning that there were so many resources, so many manifests for each given workload that we had to manage. And pretty much we realized that a good part of those resources were boilerplate. There were some application-specific kind of configurations. And there were also like environment or release specific, but pretty much you kept repeating the same kind of configuration over and over and over. And while I think other tooling like Helm was had the advantage of packaging kind of application that were written for like off-the-shelf kind of application, we were looking at. We were not going to use that anyway because we were developing our own application. So we looked at it in a different way and from a different perspective. And I think the point is that we wanted to be able to not just configure the one application, but to actually manage the full deployment, the full environment. We wanted to make sure that if you write a piece of configuration information of something that you have it within your infrastructure, you could share it across many other systems. And I think probably this is what we are going to explain today. So first of all, now, this is now jumping to nowadays. We have Kubernetes resources coming from many different places. So we have like Helm charts, which is by far the most popular way to get to get started with Kubernetes. We have Customize. We have some controllers that sometimes create new inject kind of configuration right into the cluster, and many other kind of different ways that you basically end up using every day to get your deployment, to get your infrastructure running. On top of that, there are new CRDs being added every day. So it really, if you look at from a user's perspective, if you imagine how many resources you have to deal with when using Kubernetes, it's just a huge amount, a huge number. And so we started to look at this kind of tools. So we keep comparing with what's out there. Like the most known tools are Helm, Customize, Tanka. There are many others. I don't want to include all of them. But I think pretty much the reason that led us to develop Kapitan, and we still haven't seen an alternative to fill our need, is that most of these other applications tend to focus on one component at a time, or one application at a time, and don't have the ability to capture the full deployments or the full setup you have across all your infrastructure. At least not in the way that we become used to do. They don't allow to or promote the reuse of configuration data. Configuration data. And I think in general, every of these kind of components have a slightly different kind of approach for some aspect of it. So the way you deal with the secrets on Helm will probably be different than you do it with Customize, probably different than you do in Tanka. Yeah, and in general, I think another component, I think this is something that will become more clear when, as we go through the presentation, is that all these components, all these other systems tend to defer rendering the produced manifest to the last stage, while we think that managing the compiled, rendered version of the manifest is as an important feature that helps us when we want to review our changes. So, and again, in general, these are all kind of Kubernetes centric. So at the end, it's like you have this idea that everything you will be dealing with on a day-by-day kind of is everything to do with Kubernetes. In reality, we have many other components, and this is what I mean brings back to the idea of we always call it a generic configuration system. Is that the same system can be used for Terraform, can be used for Istio, can be used for Spinnaker pipeline, can be used for Ansible, and for many other tools. We've also seen that some people are using Kapitan for generating basically a configuration for their internal or legacy tools. And we wanted to be able to, from a center point, to manage playbooks, documentation, and dashboards. I realized that in these slides, I'm pretty sure I had it somewhere, but I think it's in a little bit. I think these are basically setting up the kind of understanding of what Kapitan is and what we're trying to achieve. We're trying to give you a single place from which you can manage playbooks, documentation, dashboards, and every system that you have out there, ideally. And so basically, with that consideration, we were trying to basically have that one single thing that can control all your infrastructure. And this is basically what I'm trying to explain, to introduce what Kapitan actually is. Kapitan is effectively a tool that allows you to generate files to be consumed by other systems. So Kapitan is not a tool for Kubernetes. It's not for Terraform. It's just something that somehow does its job of creating configuration and then gets out of the way. I think this very generic approach has the benefit of allowing you to pretty much enable the same workflow and the same kind of approach when managing different classes of systems and different classes of technologies, which is unfortunately where we stand right now. We don't just deal with Kubernetes at the moment. We deal with many other kind of systems at once. I think this is, I'll stop right here. I think I talked already enough, and I don't know if you have already questions regarding this. I also realized that I don't have a view of you on the screen, so I'll just quickly move the move the presentation out of the way so I can position it somewhere else. Otherwise, I don't get any. Here you go.
All right, we're good.
Back here.
We're back on the Zivas now. So thank you for those intro slides. If anyone watching has questions, please feel free to use the comment section on YouTube. They will come to us, and we'll do our best to handle them as we go, or group them at the end, depending on how relevant they are. Now, I think what we should do is just get started, right? We're going to show people how this works, how to install it, and how to start using it. So
we sorry, I do have more slides. I didn't want to just. I just wanted to give you the time to if there was any specific question right now, unless you think we should move on. But I just wanted to quickly explain some basic concept before we move on. Otherwise, up to you what you want to do.
No, I mean, that's what I was, when I put up the website there, I was literally going to go through the key concepts to give the audience a bit of a vocabulary and what that means. But if we have slides, then that's perfect.
I think we have slides with that, and let's see if we made it clear, and if we can help us later. So let me go.
Your slides are visible.
So yeah, here we go. Yeah, now I can see myself. Before I was a bit blind. Sorry for that. So like Kapitan, first of all, comes with batteries included. I mean, the tool itself has a range of features, which we will discover through the website as well. So first of all, we have this concept of the inventory that allows you to reuse values and share configuration data across many of the systems that we will be dealing with. So you will be able to define the configuration for something and reuse it in Kubernetes, Terraform, documentation, and so on. So that's the kind of first thing. Second, the same inventory data that you have can be reused through a number of very powerful input types. So you can use Jinja, JSONet, Cadet, Helm, or other kind of tools to render, to create a template for whatever you want, whatever your task is. And I think the third important key is that Kapitan handles natively secrets with a very kind of very nice kind of a support for secrets, and we handle the majority of secrets backend with the ability to easily extend to add more and more secret backends as we go. And in general, we have an external ability to fetch dependencies externally. So, for instance, because we have the Helm integration, we can fetch Helm right from the repository, and we can just bring it in through Kapitan. So the inventory, I think, is the one concept I wanted to be able to explain. The inventory is basically becomes the single source of truth for Kapitan. So it's a YAML-based structure that lets you define configuration in different files and then merge them together in a way that makes sense to you, and in a way that I think will become clear as we start using it.
I think, sorry, Ali. I think another thing we can say is that the inventory is somewhat inspired by the Puppet era. It's essentially a tree of values that you can refer to within your programming of templates. So you can always ensure that the values exist somewhere. You don't have to have them hard-coded in your code, but they'll belong in the inventory. That's the idea.
So like define it once, use it multiple times, use it across multiple targets, multiple templates. And the basic idea revolves around the concept of a target, which is what you're working on, so your current project you're working on, and classes, which is pieces of inventory that you can share across different targets. The one new thing that we have, so if people have experience with Kapitan before, and they ran away from it because they thought it was too difficult. The one thing that we would like to show you today is this kind of new approach that we have to easily generate a configuration straight from the inventory, which I think is extremely powerful. And I think this is what, if we have to do any demo or any kind of way to show how to use Kapitan, and I think that's what we will be doing today. So there is no JSONette, no cadet at all. So if you've always associated Kapitan to JSONette, it now becomes clear that JSONette is something that can power Kapitan, like cadet or Python, but it's not necessarily the only way to experience it. And the way to describe it is like a very powerful plugin where you can define something that you want to create, and Kapitan will generate it for you. So we can go that into detail soon, but the plan is to release. At the moment, we have a Kubernetes one, which we will be playing with today. But we will. The plan is to release more and more generators as we go along. And I think pretty much this is the last part. Everything else, I think we can even go back later. But this is basically the workflow we will see today as we play with Kapitan. So you will be editing the configuration in Kapitan. Usually, with generator, usually will be editing the inventory. So editing kind of a YAML structures. Kapitan will compile and create output for you, like output manifests. And once that kind of review process has finished, you do what you want to do with those outputs. Most of the time is to deploy to your environment, but it can be anything else. It can be including, like a running script or generate documentation and everything else. And I think with this, I've covered the main concept. There is a little bit more, but I think we can go on with your demo and the website, and we can see, we can discover new things as we go along.
All right, perfect. Thank you very much, Alessandro. I mean, you've covered so much of the project there that I think I'll highlight a few of the things that I really like about Kapitan. The first one is just the way that I can actually have reusable, composable artifacts by using this, and it's not a case of like this hierarchical design, or if I have to inherit a whole manifest and then be able to like overlay tweaks in a weird way. Like I feel like that constraint is removed from me, which I think is really powerful. The secret management built in, I think, was one of the reasons that I got drawn to it in the first place. Not having to manage and deal with, sealed secrets or SOPs and other tools, and trying to daisy chain them together was a big one as well. And I guess lastly, a feature that you haven't mentioned, but I think is really important, is that every time I say the name, I sing El Kapitan by OPM, which I think is really important to having a happy working day for me. So that's really cool. Now, let's get started, right? We happy with that?
Okay. Let's do it.
Yeah, absolutely.
Okay, let's see. So this is the Kapitan website. And we are going to go to the getting started page. Or do you want to start somewhere else? I'll let you two guide me a little bit here.
No, that's good.
Yep.
Overview is good.
All right. So we need to get Kapitan installed. Oh, does that mean I have to go back a stage?
So I think if you probably the best way to start, if you go back to the home page, and if you follow the Kapitan reference, our reference repository to get started with Kapitan, which is in the community section, the third, right in the middle of your screen.
There you go.
Yeah, exactly. So I think because Kapitan basically it's a tool that obviously requires the inventory to be set up for you. So what we've done is we've created like an ideal kind of a setup that you can use to get started. And I think this is probably the best way for you to experience it. It literally as simple as cloning it and running Kapitan from there. So I think that's something that we can.
Okay, all right. We have the Kapitan templates.
Yeah. So there is we will go through this kind of a repository, but pretty much you can see that as soon as you have a terminal open and you run Kapitan compile, you will be able to hopefully see Kapitan downloading the latest image. So we're using a Docker image to speed up kind of the process of getting started. You can also install Kapitan yourself, but I think Docker image is the approach.
Universal way.
Yeah, exactly.
Yeah, so Kapitan is available through pip as well, isn't it?
Yep.
Yeah.
Yes. And so this process that you can see here, these are basically example and templates are being compiled for you. So from here we can carry on and discover how to get started with Kapitan.
So do you want to go through the slow walkthrough, or should I go back to the getting started guide? What's your preference?
I think this is basically an explanation of this repository in general. I don't know. Perhaps we can. I can guide you. So if you go back to Kapitan reference, yeah, and if you go to the top of the repository, sorry, if you go just scroll up a little bit, and there is a just after Kapitan reference, there is a manifest generator documentation. That could be a good way to kind of get started. It's kind of assuming that you already know that you need to create a target. So I think the one thing you will discover is that we need to work more on getting Kapitan to be used more easily. But yeah, basically, if we go here in the repository and you navigate through the targets, inventory target folder, yeah, and you can create a new file if you want. So call it like demo.yaml. So this way we're basically telling Kapitan we want to create a new project. We want to work on something new. So if you compile now, if you run the compile process you ran before, this is something you will have to do it quite often. So perhaps, I don't know if you want to have a view right in Visual Studio Code. I think that will be quicker. But the process is always like you edit something, you compile, and you see what happens, basically. So
just one minor thing. Sorry, there is a limitation at the moment in inventory. Your files need to be .yaml without an A, so YML, not Y.
Oh,
yeah.
Well, good spot. Yeah. Yeah, go for it. And so you will see, hopefully, your...
Also, you have to put stuff in there, right?
Oh, yes. Okay.
I did wonder what it was going to do with an empty YAML file.
Yeah.
Like, is it just going to magically make it up? Like,
I don't know. I don't know. I'm just going to say, the fact that it didn't crash is already a good sign. So the target is we just need to add a little bit of boilerplate. So if you create like the top bit, in the top part, if you write classes and you create like a list of classes, and the first one is common, that's the boilerplate you need. And I think from then on, you can probably follow the rest of the documentation you have now. So if you go back to that the page that we opened before with this one, so you can I think already start using with this generator. So as I said before, the generator is like something that allows you to quickly create configuration for you. So in that case, we will be creating a configuration for a component called the Eco Server.
Okay, can we then just take a moment to maybe explain to people what a target and a class is in this context?
Yeah, so this is something I went through in the presentation like briefly before, but basically a target is like your leaf file to get Kapitan started. So you define a target, and that will usually be mapping to a manifest or a number of a namespace, a Kubernetes namespace, or like an application, something you want to work on. So it can be, if you're working with Kubernetes, most likely will be all the application that you want to stuff into a namespace. If you're working with Terraform, it could be like a project that you want to create.
So would
if you're
that
working
map or correlate? Like when I think of a target, would that be like my production environment? Would it be my staging environment?
exactly.
It's up to you, really. It's really up to how you or your team work. Some people share environments, some people share clusters, some people share namespaces. So it's really your deployable group of stuff in a way. That's how you should think about it. So here we'll call it namespace, but essentially it's a target. That's what it is.
Yeah, some people ask us that question, and the thing is that the inventory in Kapitan, they are so generic, and you can reuse in whichever way you want. That ultimately it depends on, once you get the feel for it, you will understand how to organize it. Sometimes it's a namespace. In some other cases, perhaps you want to define an application that you want to deploy to many clusters at once. So how you use it, it's up to you. Our typical way to use it is to define all the applications you would want to install on a Kubernetes namespace, which I think is, in this case, we will be defining a target called demo, and we will write all the applications that we want to create within it.
Nice.
Okay.
Perfect.
And classes is still an inventory file. While the target is the first one Kapitan goes to look for, classes are other YAML file that looks exactly the same, but they group other kind of configurations. And so they're used for sharing that kind of information with the target. So as you add a class, the class will bring in all these other kind of values from the files that are defined, and ultimately you will create like a merged representation of your inventory, which will be composed of all the classes you have imported plus the definition you have at target level.
So one thing that we can also show in a minute is, this might be a bit hard to picture mentally how it ends up, merging everything. So you can run the inventory and on the command line, you will see it rendered. So you don't really have to try and understand what will happen. You can actually see it before you create anything.
Yeah. So now if you run Kapitan inventory -t.
Or that.
Space -t and then demo, which is your target. You will basically see the inventory that so far has been created for the demo target you're working on. And this is basically brought in by the common boilerplate kind of a class. And I use that word, but basically it's like a predefined set of configuration that allows you to get started with it.
Okay,
From there,
try and summarize that a little bit, right? So I think the targets were well explained. They're groups of things or targets, like namespaces or environments that you wish to deploy to. Classes can be as small or as large as you want, and they can be composed together. So you can have loads and loads of small classes that can be grouped together by some sort of aggregator class, allowing you to, really get down to the nitty-gritty of small tiny classes, but then provide a single class to deploy to your targets. So a really flexible and composable solution, which I think is key for people to understand.
Yeah, I think the key aspect which I like to talk about is the fact that the class you can name class whether in whichever name you want, which usually it's helpful to map them in terms of business concept, or at least things that are related to your activity. So if say that you are changing a value for a Java server that you want to have more memory, rather than just write that kind of a value in a values file somewhere, you can map it as a profiles.production or profiles.high memory. So it allows you to basically group together values that would normally not have much meaning, but you can attach some sort of a meaning by just naming the class in a way that makes sense to you.
Yeah, although a Java JVM needing more memory is completely unheard of. So that was a terrible example.
Terrible example.
Sorry.
All right. Okay, so we have our wrong folder. We now have our demo target, which is pulling in the common class. We can take a look at the common class here. We can see that it's just pulling in another class, Kapitan common, and we've got a few parameters that can be provided. Okay. what you want to go back to the manifest generation step, right?
Yes. So if you now cut and paste this first part, so the that one, and you add it to the target. Yeah. So here is where you start basically adding your own custom setup to the target. So you're defining something in the parameters. So classes and parameters, you will see them replicating in all the other classes as well. And here what we are doing is we are defining a special kind of, through a special syntax, we are saying, I want to basically create a new component. I want to call it Echo Server, and I want to have an image called like that. This is a beautiful project I always use. Very easy to get started, like a web server, and it's very easy to play with it, basically. So if you compile right now, you will see a couple of things happening, and we can go through that as they happen. So you see your demo being compiled up there. So next time, if you compile with -t demo, it will speed up, and we only compile that specific kind of environment. I think that's if it takes time here, it's for Docker, it's not us. So if it takes a little bit longer, a couple of seconds longer, it's just for the fact that we're using a Docker image. Okay, now when you compile a target, the output gets produced in the compiled folder. So if you do git diff now, or if you go and look at it through, git state or so to have a look at the files, you will see that several files have already been compiled for you. And the one for your target will be under the compiled demo. So the manifest folder is the one where we will be interacting with the most, because that's where the generator places the files that you're creating. So if you in the editor open that folder, you will see already that there is already some magic happening there, and we can go through to basically explain a little bit more what's happening. And so with the configuration you've defined allows us to say to generate the default object that we use most commonly, which is the deployment. So it's just basically getting rid of all the boilerplate and adding all this kind of a sane initial setup for your generator for your deployment, in a way that you have something already working out there.
Okay, can we maybe try and break down how we got from this to a deployment? How does that generator work and interact with what's going on?
So the generator is essentially a plugin that we have within this repository we have installed here, that basically activates on whenever you define the structure you have here, and then you can expand it to add more value, so to add more components. So every time you find something under components, it will basically take that object and try to do something with it. So I hope I'm not going to get like ruined for what I say, but it's a little bit as if you had like a CRD. You define your own CRD of how you want the deployment to look like. I've used a very bad example here, but it's like you are defining like something that you wanted to turn into a more complex kind of a representation. So in this case, we want to create a component, we want to call it Echo Server, and we want to have that image. And we can see how we can build on that quite quickly.
I think one more thing we can say. Sorry, David. One more thing we say is that every inventory has the classes and parameters. Every inventory file has the classes and parameters keys. The parameters essentially feed the input parameters to a template. And in this case, the template is what Ali said as what we've brought in by cloning the Kapitan reference, Kapitan templates example. Right. So we already have a baked-in template for you to use. And another way you could use this, you can actually write your own templates, but for the demo's purpose, we have a baked-in template for you. So that's why there's a lot of magic happening. So what we've just done when we've done compile was we have now created a new directory compiled, and we've added a new target, which is your demo target, with all the files that it generates for you. And in this case, it generates a bunch of Kubernetes manifest files based on this input from this target.
Okay, now would it be fair to say, in my naive assumption here, that this components and echo server keys correlate to this file, this Ginger template file that we have over here?
That's a coincidence for now. We will use it. We will use it. It has nothing to do with that. So this is the bit that is difficult to get. It's like, while with Helm, just to give an example, with Helm you have value files, and then you have templates that are made of Golang templates, basically, right? The text templates. So you see that kind of you're now, what you're doing is you're looking around and you say, okay, where is the magician hat? Where are the templates coming from, right? What we have effectively is what we called generator, which you were right to go on the components. I think if you go to components, generators, Kubernetes, that's it. Don't look into it. Don't open it. No, I mean, it's just Python code that basically using this software. No, I'm kidding. You can open it if you want, but it won't look nice. It's basically Cadet, which is a kind of our own kind of language that Ricardo has written, that simplifies the generation of manifests or files or templates in that way. And so that kind of generator is being created to react to the configuration that you define. So if you write components echo server image, it will create a deployment with that image.
Okay, can I test a hypothesis then? What if I Nginx image, Nginx latest, and what if I just start going a little bit crazy here?
Okay, you need to get the right setup, but that's the general idea is correct. You're close to it. So Nginx, perfectly fine. Image Nginx, perfectly fine. Ports, rather than making it a list, just add the HTTP under that. So like create another key under ports, HTTP, and then add the container port, but with the and then container underscore port, because that's how port 80. And compile away, and please make it crash to embarrass me in front of everybody else. Go for it, and let's see what happens. Please don't crash.
It works. There we go.
So what do you expect? What do you expect to happen?
So I would expect to see an Nginx deployment with this image and the container port configured with a name and exposing port 80.
All right.
Exactly.
You got it there. Yeah, there you go.
All right, let's see. So
okay.
Nice.
So now you're wondering how far we can go with this, right?
Yeah.
Okay.
I mean, maybe you could help me understand why, because this is starting to look like a pod spec. I know it's not a pod spec, but this is probably going to be unfamiliar to people coming from Kubernetes.
Mm-hmm.
How do I learn how this generator works then? How do I know what other keys are available to me?
So if you go and look at the page that you skipped through because you are so excited to work on this, you can basically understand a little bit more about how it works. And I think the easiest way is to go through the examples that we have, and we see what we have available. You're right. Obviously, this is a Kubernetes generator, so it looks a little bit like a pod. But there is a bit more. So some of those commands apply to the pod. Some of those kind of definition apply to the pod. Some other apply to config files or secrets. And I think as we go through this, you will understand all the other capabilities. So if you skip these two kind of main section, global general setup, and you go to ports and services. So here should explain exactly what you were working on. So you've created like a port setup. So you define a port with a name, so HTTP port, and then you went for container port 8080, which is intuitively you got very close to actually the configuration of this setup. And you can basically it's a a new format that you need to learn. So obviously you need to learn how to configure it that way. But the main advantage you have already here, and you can see over the other software, is like, and by all means, I use Helm as a comparison just because it's easier to, most people know it. It's like, while with Helm, you still have to do pretty much the same job in the values file, right? But each values file drives the template in perhaps a completely different way, right? So depending on the template, you will have a different value file that you need to, every time you have a new chart, you need to go through the values file and understand how to fill it in to make it behave the way you want. Now, obviously, there are standards, and people tend to use templates in roughly the same way. So the values that you define are pretty much always going to be the same. But that's down to coding standards. It's not because Helm enforces you to have a specific structure. In our case, those definitions, once you learn how to use it, you can use it to create any other kind of template you want to create. So it's a good reuse of those configurations right there.
Okay, well, I love what this one is doing, so I need to see this happen. I mean, this is, 9 times out of 10, and that's an arbitrary but probably pretty close number. 9 out of 10 times, what I'm doing with Kubernetes is deploying a deployment that has a service that exposes that thing, right? And
exactly.
To just template that down to something as simple as, hey, my target should have these components, and this is how I tweak them ever so slightly. Is fantastic.
And at the moment, for the benefit of the demo, at the moment we are doing everything in this target directory. You won't find a service there yet. Just give me a second, and we create a service as well. But like at the moment, we are doing everything in the targets file, just out of convenience. But effectively, you will be moving this kind of configuration in the more appropriate class later. But for now, let's carry on. So to have the, if you now scroll down and you find expose a service, and then there should be a service directory directive as well. So okay, so if you go back to the target.
Yep.
And let me make sure that I don't make a mistake there. But if you write service, so you create a new key called service alongside ports. Yes. Yep. And then another key type, and you say cluster IP. Mm-hmm. Yeah. Now, if you compile, so here, I think this is the one problem that we have right now, is that possibly we haven't been extremely. I might have made a mistake there. Just double check with. I think you're right. So if you go on, create it? Oh yeah, just look inside the bundle. Yeah, exactly. Yes. Now, this is one of the things that annoy me the most when I start using Kubernetes, is that you have to match the labels across deployment and service. And I was like, it's a beautiful kind of power ability to decouple the service from the Kubernetes. But how many times do you actually use it like that? It's like it's just gets in the way sometimes when you want to do things your way. So that's why the default is to make sure that the deployment is called Echo Server, the service is called Echo Server, the labels are consistent across the two, and you carry on building the service as you need. If you need to deviate from it, you can still do it. But for the time being, this is an ability to quickly get started with it.
So does that not have an implicit cluster IP by default? Will that just now remove that from my bundle?
It will, and now it will remove it. Yeah.
Right. Okay. Cool. Right.
Okay.
Nice.
So, yeah. So I think if you go through that page, you will be able to see other examples, and I think if you look in other kind of components classes, you can understand a little bit more what you can do. But let's carry on with what we have here. So if you go down a little bit, let's see what else. Yeah, like liveness and readiness checks, if you want to add them. So I already defined the fact that it can point to the specific port. I just hope that I haven't checked that page in quite a while, so I'm just hoping that everything works. in case we can route immediately to an example that is already built for that. Yeah, there we go.
Sweet, there we go.
Okay. Now, obviously, go for it, Ricardo.
I think one thing we should mention is that when we briefly mentioned in the slide of the workflow for Kapitan is that you are just generating stuff here, and the idea of how you should use is really you generate the compiled files and you check them into your Git or whatever, and then these ones are deployed as they are into the cluster. So it becomes really super easy to know exactly what you have in the cluster. It's basically your snapshot is your state is all defined in Git, as opposed to, for example, Helm or other tools. You don't really see by default what it is actually rendering and applying to the cluster. You just have that view of the parameters you are exposed to, and everything else is kind of magic unless you dig into the code. Our approach is a bit more verbose, which might be a bit more overwhelming at first, but eventually you have a much clearer picture of what you're applying to your cluster.
Excellent. Okay, so what should we want to look at next?
Let's look at ConfigMaps. I think that's where the fun starts from my point of view.
You've not been having fun yet? Come on.
That's the boring stuff.
So obviously, one of the things they use most of the time are like, again, config maps and secrets. And with the generators, you basically pretty much define it exactly the same way. So if you now copy and paste that into your configuration, you would see more magic happening, which is basically, add it wherever you want to, whichever component you expect it to happen. So this is just make sure it's indented. Yeah, it's the right indentation. Yeah.
So here I can add key and secret, value pair, whatever, and that's just going to work.
Yeah.
Yeah. So what we tend to do is every time we make a change, you like git commit so that then you can easily see the diff of what you're changing. Obviously, in this case, it's we're just playing with it. But as you can see, has generated another file, nginx config, with that content. And the nice thing is that on top of the simple value that you can define this way, this is just to add value to an echo server. We also support to the idea of connecting, of rendering templates that come from an actual Jinja file. So the one, the Jinja file you pointed at before under the components folder, that is just a file that is there that we can now reuse and see how it works. So if you remember that you were in the components folder and there was a Jinja file that you pointed at before, So we can now tell the generator that you want to use this template in the compiler in the example we are doing. So if you copy that components echo server, if you copy the path to this file, and then we can define it here, and you call it another name, so create another key, saying like example.com for.
If you go one level before.
Yeah, it just
insert data.
Exactly, and then add a key called template, and then you put that path, and then you add a another key.
Oh wait, I'm lost.
So echo server conf.j2. Yeah.
I mean, this is just an example. We have others, but pretty much any other. And then you add another key called values, which is where you basically specify the context. So in this case, if you write example, which is what the variable that kind of a template is looking for, right? Hello, and compile away, and let's see what happens. Yeah.
Boom. No, it didn't crash. Great.
I'm just waiting for that to happen. There we go.
There you go, yeah.
So very simple, very quick to get started with it. Now, in the values kind of key that you defined, you have access to the full feature of the inventory, which is variable interpolation. So you can now take a value from anywhere else in the inventory and write it there instead of hello. So for instance, if you write $, open bracket, curly brackets. Yeah. And then something like a target name, just to make it easy. What we are saying here is we are telling Kapitan, or we are telling the inventory, to replace that value with the inventory value called target name, which can be defined in any other class as long as it's within the inventory. So this is very powerful because it allows you to basically refer to other kind of values that you have configured somewhere else. So now, again, if you compile, you will see the expected change. Hopefully. So far, okay.
For this demo. Yeah.
It can be much more complex. So if you look at the example for inventory classes components MySQL, likely I added it right yesterday. A bit more. So inventory classes components MySQL. So this is obviously a little bit more of a complicated setup. If you want, we can look at it later. But pretty much you can see other kind of configuration, and you can see that the templates here reads the settings block that you see up there. So we are referring to another kind of part of the inventory configuration. Allows you to easily play and change with these parameters as you create different components of MySQL across all the different components.
So I think one thing we can also look at is what he's mentioned before is if you go back in the terminal, David, you can type Kapitan inventory -t demo -F. Yeah, so it flattens out the inventory and it renders the inventory. So now you will see everything rendered for you. And for example, you can grep for target name. Well, there you go, right? So this is just a simple example of how you can visualize the inventory rendered and how you can actually use other values within the inventory in your templates or within your classes, whatever. Okay.
Nice. All right, we have a question which may be quite tricky, but I'm going to give you it anyway. So Sharaf is asking, is it possible to give Kapitan knowledge of what Kubernetes version is the target so that I can adjust the API version and kind appropriately if needed?
Yeah, so the current generator doesn't do that, but we are planning on allowing it. At the moment, we are, this generator is something that it was originally created a Synthace, which is the company that where I'm working, and I've then converted into Cadet. We are adding more and more features, one of which is adding schemas and adding the ability to also target a specific Kubernetes version. So at the moment, it's not possible. So we tend to default to the latest version available, but we see that that's something that is needed. And it effectively wouldn't be more difficult than just defining somewhere, an inventory value that points to the Kubernetes setup that you have, and then from that it will understand what version to use. So not possible at the moment, but definitely something feasible.
And if I might reiterate a little bit, not possible generators. If you use plain Kapitan, you are completely free to do this feature yourself, if that helps.
Yeah. So this is an important thing. So if people have experience with Kapitan before the path to do what you've done now was to create like a JSONet file or a cadet file for each component, and then every time you had to repeat pretty much the same stuff. So you could reuse some things. But like in this way, we realized that pretty much all, like in our situation, my company, we had like microservices all configured the same way, but with a couple of variations. And I just got tired of dealing with all those different kind of variation across them. So I think there must be a better way, which is what led us to use this approach. Do you want to continue with more fun? I think we have a couple more things that might be of interest. So first of all, the same setup you see now with ConfigMaps. If you even just create, instead of ConfigMap, you create the same setup with written secrets, it will work exactly the same. So interface for both of them is the same. And you can do all the things that you're expecting out of a same setup. So you can mount the config map into the pod that you've defined, like that. Yeah.
That's the MySQL one. We can close that. So here I can just say that I actually want to mount this. Yes,
under that directory. And and it will do all the needed configuration for it.
And if I pop open our bundle again, we should see we have our volume mount configured.
Yeah.
And our volumes here. Very cool.
Yeah. Now, the standard setup that we have is that every time you create like a configuration config map, it's named after the component you define. So if you have only one config map, it's named after the same component. Obviously, this doesn't work if you for any reason you need more than one config map defined. In that case, the name morphs to be component name and then the config map name, so that you can have a the default is to make sure that it's as easy as possible to refer to that specific config map. Yeah. So we can also. I don't know if we have all the explanation here, but you can also mount only specific files, or you can also just you can also do the subpath mount. So you can say, I want to just mount this specific file under this directory. Not sure if we have documented all of it, but it's all possible, and it's something that in any case can be improved very quickly.
Right.
Oh yes, there it goes. Filtering files to mount. There we go. Look at that.
Oh yeah, so we can use an agency. There we go.
Yeah.
And then secrets are pretty much just the same thing, right?
Yeah. The only difference is that you also have the ability to base64 encode it. So if you create like a simple value and you want to base64 encode it, it does it for you. That's the only difference with the config map, really.
Okay, and we have the ability to hook into various cloud KMS systems or local GPG in order to actually store and encrypt those secrets in a safe GitOpsy fashion.
Yes, or the best of them all, base64, the most secure of them all. Obviously, it is the setup.
I don't even use that. I use string data key and just YOLO it all the way. So
yeah.
So like you won't be able to use this example right away now, but if we just accept the fact that we are in a demo and we are all friends, and if you copy this and you change GKMS with you replace it with plain. So under the yes, that's perfect. Yeah. Yeah, just change it to plain. So let's pretend we are on a safe network and a safe internet. This is, I think, if you compile, I think it gives you a very good idea of what happens. So so this is base64 encoded. So you have to decode that.
Let's prove it.
But basically, the important feature that I would like to point out is that Kapitan's when generating a secrets, Kapitan has a number of functions that you can use to bootstrap the value of that secret. So you can automatically generate a random string, automatically generate like an RSA key, and relative kind of public keys, and we can add more and more function as we go. And I think this is what we call like declarative secrets in a way, with a very fancy name, because what we want to do is capture not only the fact that you have a secret, but also how you generated it. And I think that's quite important. I think it's a nice approach that we tend to use, and we tend to tell people to go for.
I think one cool detail is that if you go back to your previous file and you change plain to base 64 and then you compile again, you will see something a bit different. Right. So that is what we call the reference. And if you check the Kapitan.dev documentation, it actually calls that a reference, which means that it actually points to a state that is saved in a directory called refs in your repository, which means that the next time you compile the same thing, the reference to that compiled state is reused. So, for example, if you were to use real encryption, not base 64, it's not encryption, for example, GPG or GKMS, you are the developer, you are deciding what the secret is like, you commit that. The second developer does not necessarily need to have access to the same secrets, but he can still recompile stuff and have the same results, right? Decrypting is a different story, but that's the idea.
Yeah.
And so when you apply, you have to reveal the file, by the way.
And if you look at now your directory, there will be other files being created under the refs directory, and those are the one that I think Ricardo is referring to, that hold the information about the password. So in this case, we are basically generating the password, writing into this reference file that you check in. Obviously, not the base 64 one, but when you use a real backend, like a secret backend, you can securely store with you the encrypted version of that password, and you can share it around only at the act of revealing. So only when you need to apply that configuration to the cluster, only then you need the permission to read that secret. So all your other colleagues can be using Kapitan without having to need access to these secrets, which is already, for instance, a difference with, I must say, I don't use other tools, obviously, but like if you use Gitcrypt or if you use other alternatives, I think pretty much you need to set up your environment to be able to read those secrets, even if you are not the person that is meant to consume those secrets. In this case, there is a nice property, is the fact that you only need to reveal these secrets when you are applying this kind of configuration to the cluster, which is something that we can also delegate to another project we have, which is Tesoro, which is basically a tool that runs in the cluster. It's the only one that needs to be able how to decipher these secrets, and then everybody else can be locked out of understanding, even understanding what the secrets is about.
Cool. Very powerful secret management there, I think. Lots of flexibility and just being able to hook into those cloud KMSs, I think it's important. We shouldn't be using, I would argue we shouldn't be using local GPG or shipping around private keys and things like that. This is how cloud excels that.
This is something I'm trying to get people to understand, is that even if you have your own kind of bare metal installation of Kubernetes, you can still use like KMS from Google or KMS from AWS. You can use just those tools, and they're so cheap to use that it doesn't even make sense unless you have a specific need. Bringing up the whole Vault setup just to make sure that you have these capabilities, it doesn't make sense to us. So that's why GKMS is standing over the AWS version of the Azure version. If you really fancy trying all the different clouds, they're available for you through Kapitan, built in, and you can just get going very quickly.
Yeah. I often work with bare metal Kubernetes environments, as I think you might be aware, and I often use GKMS pretty much. So it's just, yeah, you're right. It's almost free to a certain point, depending on how much you need to access it.
Yeah, definitely.
All right, let's show off some more cool stuff before we finish off then. Anything you want to lead us towards?
I think this is something that I think you got to the other nice section I would have wanted to explore. It's the fact that so far we defined basically things that are related to the deployment, secrets, and ConfigMaps. You know, the typical stuff that you normally expect to have in a deployment. But sometimes there are kind of other features that you want to, other kind of characteristics you want to build into your deployments, which would normally require you to have a specific template just to deal with that. So the generator takes care of that. So like in the case of network policies, if you define the network policy kind of block, it will create a network policy for you. Prometheus rules, if you define the this kind of setup, it will basically automatically create all the Prometheus kind of configuration that you, all the kind of CRD related to. This is the example where you're using the Prometheus operator. And the same, if you go down, there is another service service monitor. So now if you cut and paste this into your configuration, you basically, by adding a little bit of an extra configuration bit, you can generate many other associated ancillary kind of resources that logically belong to that application. So within the same application, you can define many other kind of behaviors without having to deal with a specific template for creating service monitoring and network policy. And also, while with other tooling, again, because they require you to have the templating specific for the feature you want to enable. So if you are unlucky enough to use perhaps a chart that hasn't been looked after properly and probably doesn't have the service monitor configuration, I think you need to add it yourself. I don't use it, but my understanding is that you need to go and add the template to that chart and make sure they work for you. But if you go down the generator route, you can basically every feature we add to the generator can be used by any component you define.
So is that to say that I could have Kapitan reference a Helm chart that I'm still using, but I want to enrich with new manifests, and Kapitan can generate or compile them into it for me?
So that's what we will be working on. It's not possible yet. What I meant is that both the Echo server and the Nginx that you defined can both benefit from these kind of features, which is something that, like you can have like 20 components and easily add to all of them consistently the same configuration, the same service monitor configuration, and the same kind of network policy, like consistently across all of them. So I'm just saying that even if there is a feature missing of the generator, the moment in which we add that feature to the generator, it automatically is automatically available to all the manifests, all the definition you've created of all the components. I don't know if that was clear. If you feel like if I can explain, if I need to repeat that again, but I think I found it interesting that we can easily add more and more magic kind of a generator kind of incantation, and the moment in which we add it to the and we publish that kind of a feature, it's available to all your components that you've defined through Kapitan. So it's very easy to deploy a feature across all of them.
Yeah, that makes sense. Awesome. Okay. What next? I think that's the end of the reference, right? So we kind of covered the generators, how they work, what they do, what's coming. I mean, we've covered quite a lot there. Is there?
I think we can pass some of the stuff you pasted into the target into a class. So just to make a target a bit neater, right?
Okay. So
yes. So to be honest, you can also, or use a class that we have there. So if you want, you can, so the Echo server is something we define already. So if instead of defining your own version, you load a class called, so if you in the classes section, if you load the class called components Echo server, which has already like lots of configuration defined, which beyond what you had before. So if you just load that class, it will basically inherit all these features automatically. It's like an example class that we have there. And at the same time, if you want, you can install MySQL by just simply adding components MySQL to the classes section up there.
Yeah, so we could, in theory, I mean, we could just remove all of this and use those classes that were provided, right? So that would be...
And I think this is good because we can show you how you can override the content of those classes, which is something that until now we didn't need to because we were doing it right away.
Yeah. We can do that, right? I think that's okay.
Yep.
Yeah.
That's fine.
And then we can recompile, and we'll end up in a pretty similar place, except now we're going to have an added MySQL bundle and our modified Echo server. So
yes.
See. So we've got our stateful set for MySQL, and where is our Echo server? Very, very similar. Nice.
Yes.
Yeah. And if you look at the Echo server class now, the inventory classes component Echo server, you basically it's probably the most complete example we have. So that everything you can think of has been added to this class. But we can see that another kind of, you have network policies defined. You have a side container as well, additional containers. So you have a side container with Nginx, which is also nice. And you can see that pretty much the configuration is pretty much the same. So pick something that you want to override, and we can override it at the parameter level.
Yeah, so I guess something that may be common then, like if I wanted to deploy this Echo server across multiple environments from staging to production, then the probes may change slightly. Like I may in production be a little bit more hesitant or a bit more aggressive with the timeout, whereas in staging I may give it a bit longer.
Exactly. So we can do that, right? So in the target, because it's a demo environment, perhaps the timeout, what we want it to be, instead of 3 seconds, it can be like, I don't know, 10 seconds.
Yeah, 10 seconds. Why not?
Yeah. So the way it works is that if now in the demo target, you basically recreate the YAML structure up until the parameter you want to change. So it will be components, Echo server, liveness check, I think it was called, with underscore. I think it. Yeah, and then timeout. Yeah, just make sure
it's the same.
Yeah, exactly.
Echo server, and then we come down to health check, liveness, timeout seconds.
There you go.
Health check. Timeout seconds.
Yeah.
And what we should see when we recompile this then is that our Echo server bundle, we're going to have this timeout on the liveness probe, which is here, and we should see line 40 change to 10.
Yeah, which is where committing it to Git, like an helps in this case, because you can easily see the diffs between them.
There you go.
Has it changed? Yeah, changed.
Yeah, it changed.
Now this is an important thing that I think you can go back to something I said before. If you go back to the target, what you've done here is to add a timeout seconds. But the reason why you wanted to add the timeout second is because you said it's different environment type. So if instead of doing it this way, you create a class called, like a subdirectory called profiles, and then you say, I don't know, testing or demo or low latency or whatever you want to call it, you can then copy this configuration that now doesn't make sense. In 3 months' time, you won't remember what this is about, right? But you can add it under something called profiles, testing. Testing. You come up with a word that you like.
So we add a new class?
Yes, exactly. Create a new class called whatever you want, like I think staging. Like environment staging.
Let's call it forgiving. Let's use the forgiving.
Yeah.
Forgiving is good.
And then we call this whatever we want. So let's just say main.yaml.
Yeah.
We're not today. Sorry.
Oh.
Something we need to work on. Yeah.
And then from here, I could just augment this with my forgiving main.
Yeah.
Forgiving.
Now you managed to turn into something even more difficult to understand what he was referring to, but you get my point, right?
Well, I think in my head, what I was thinking is like, there are certain constraints that I want to apply to different environments. And forgiving was a terrible name, but I'm going to be running maybe consistent performance testing on this environment. I may have debugging tools enabled, so things will generally be slower. I may have chaos being artificially injecting timeouts, whatever. So being able to group these together as a component that is reusable to apply to the target environment is kind of what I was going for there. But maybe
exactly. And I think something else you can do, just because we're playing with organizing it better in the forgiving main, or even in the echo server setup. Instead of defining the timeout like this, you can actually define timeout seconds on the under parameters. Exactly, you're already there. Yeah. So this means that now, and especially if you apply to other components, it means that you can define that across all the components that you have around your, all the components you're deploying. You make sure that you consistently apply to all the different kind of deployments you have.
And also you can go ahead and duplicate that target and call it prod and then change the value. And now you have two very similar targets.
Now I've got it. Now my forgiving name is getting worse and worse as we change the behavior. But
the name should be something that makes sense for you. If it makes sense for you, then we're good, right?
Yeah, you're right. Okay, so and then, like you said, we can say, hey, actually, we're going to have a slightly different performance testing one. So, wrong.
Yeah.
No, that's right directory. Okay. Performance.yaml. And actually, we really want to test this, and we're going to go with a 1. So now this needs refactored, but that's not today's lesson. So,
so basically,
I think this is. Sorry, Nico, Alessandro.
No, go, please.
I just, I love confirming why I really enjoy working with a tool, and it's just this composability, the way that we're moving things around and grouping things into use cases and behaviors that we want to then augment into our targets. I think it's just really powerful.
But there are some aspects of it that you will become even more clear as you use it, and it's something that I had a colleague of mine that used it for several kind of weeks, and then he did like a refactoring of the inventory to just shuffling things around, and he compiled, and he didn't see any change in the compile folder. It was like, oh, something is broken, something is not working. But that's exactly the beauty of adding the compiled files together with the template, is that you can refactor the inventory or the templates as much as you want, but if you don't change the kind of a functional behavior of what you're doing, you have an immediate guarantee that whatever you've done hasn't disrupted your workflow. So now you can move things around, and it doesn't change.
Yeah, kind of like TDD for your manifest. When you're refactoring, you want to make sure all your tests pass. Here, you'd want to make sure your output doesn't change. So
So what we
actually, you can write tests for it, right? You can write tests to validate your YAML. So it's completely up to you.
Yeah, I can imagine once you do the compilation step, being able to run some sort of OpenRego against it to, make sure that it conforms to all the rules that we have in place for those environments would be really powerful as well.
Yeah. So before we had a JSONet-based generator. So when I wrote the Cadet-based one, the Python one, the only thing that changed was the speed of compiling. But other than that, it was pretty much, it produced no output, which gave me the immediate guarantee that whatever I had done, I was able, with the Cadet version, to basically recreate exactly the same behavior in the JSONet version. And so you have an immediate reassurance that what you've done hasn't impacted any component. Yeah.
Excellent. Is there anything else that you would like to cover before we finish up for today? What's your
What
favorite
other
feature? Have we touched on it? Have we done it? Have we shown it?
We've touched on a lot of stuff.
I know there was potentially going to be a demo. Did we cover everything that's in your demo, or would you like to go ahead with that?
Yeah, pretty much. Basically, the only thing I was going to do is go through exactly the same, and I think we've covered everything. I think another bit that we can show, actually, we can even tell without even having to go through the pain of recompiling. But you can add, if you want to have virtual pod auto scaling, you just do VPA auto, boom, it works. If you want to have a pod disruption policy, you just define pod disruption policy and it works. So it's all kind of small other kind of features that we can add, and we've added to the generators so that you can easily take advantage of other kind of Kubernetes features that otherwise would have to be maintained manually. Yeah, I think it's auto. Uppercase auto. Let's see.
I'm not going to miss an opportunity to see if I can add a VPA to this. So
I guess another thing we can do is just really show the scripts, which is probably a controversial feature, but you can actually generate executable scripts, which we already do. There you go.
Has he added it?
Yeah.
Added it, yeah. Oh, yes, I went too far down. There we go.
There it is. VPA, yeah.
Nice.
Yeah, so if you now open another target file, so for instance, the tutorial one, there should be one called tutorial.
There it is.
So in the top part, you see that project localhost Kubernetes kind. So if you copy and paste that into your configuration, into your target file. Yeah. So, and compile. What we are doing here is that and you can open that class to see basically what it has. We're basically, you will see here changing the scripts file, which is actually was already there. What you see now is that we've basically imported information about a specific Kubernetes. As you can imagine, it's called kind in this case. And do you have kind installed on your machine just to prevent? Actually, open setup cluster. Yeah.
I do have kind available. Yes.
Oh, great.
Yeah. So now, if you run on the terminal, compiled. Just execute it right from where you are. So compiled.
Demo scripts.
Demo scripts cluster. Yeah, go for it. Let's see if it works. I mean, this is, I think. The
demo gods, man. So far, they've been with us.
Yeah, we haven't broken a single compile. I mean, you just have to break it on purpose.
This is insane. This is live typing, I promise.
And I think the time it takes for here to set up to remind everybody listening on the stream to retweet and talk about Kapitan and sponsor us if you can. We are basically we are. Yeah, and file all the bugs you find. But we are going to spend much more time to make it working this year. So I think we are on a good path. I think we have a good idea, and it would be nice to see more people taking advantage of it.
I guess adding new automations to the generators could be a really good way for people to contribute. Adding new keys that then get expanded into behaviors that they want to see,
exactly.
trivialized.
So the beauty of the generator is that, for instance, we can create now a Spinnaker generator. For instance, in my case, we use Spinnaker at work. The Spinnaker generator can see the compiled echo server, the compiled deployment you've created, and based on that, it can create a pipeline to deploy those kind of configurations. So, and then if you add a secret, it will automatically instruct Spinnaker that now there is a new manifest to be deployed. So actually, by using the same kind of a configuration, multiple generator can provide a different behavior. So if you add an Argo CD generator, it will create all the Argo CD configuration that you need to deploy your configuration. So I think the generation pattern is something that's trivial to add, and it will give a loads of benefit to the people using Kapitan. So now if you do and run compile demo scripts setup context, and you actually don't even need to run this because it's automatically when you run kube control, but yeah. And then you run kube control get pods. Get pods. Yep. I mean, there is nothing now, but yeah. And then if you instead of kube control .sh, you run apply.sh. Yeah. And here we actually see if we've generated rubbish or if they actually, yeah, here we go.
Yeah, our secret.
Okay. No, it's a secret. Yeah, exactly. And the vertical pod autoscaler, I think it's a different version. Just to, I need to update that. I think you're
ties
using
in well with that question we had earlier.
Exactly. Yeah, I was just going to reply to. It's very relevant to that comment. But basically, the point is here, if we just take away the good part of it, not the fact that it crashed, is that it enables you to create scripts that are already configured to operate with a specific deployment. So it doesn't matter on which context your machine is pointing at. You can, you know that you can run get pods under using this script to point to exactly the version that you want to have, you want to be working with. So the same thing is that if you now go compiled tutorial scripts apply right away. So we try this, and probably will fail for the same reason, but it basically will recreate the context and deploy these values without you having to do anything with it. If you do, yeah.
So this is a very powerful abstraction. I mean, for people who work with Kubernetes every day, fine, it's perfectly obvious. But we had people who were not so familiar with it, and they got extremely confused with the difference between namespaces and contexts and clusters. So the idea is that we can actually template all of this in a script that is runnable, and the script is basically omnipresent, right? You run that, and it just works for that particular setting. It doesn't work for anything else. So you basically end up running the scripts for the target you
I think you're breaking up, Ricardo. I don't know if it's just me.
No, it was okay my side, I think.
Okay, yeah, so it's just me then. I know about all that stuff, so it's fine.
All right, excellent.
Yeah.
Do you want to show anything else? Last chance.
I think the only other example that I would like to show is if you look at, so you open briefly the WeWorks class.
Yep.
So if you go inventory classes.
It was there.
I have the feeling I have inventory classes. Yeah.
There we go.
Components, workshop. So now here basically I have replicated all the configuration for the WeWorks sock shop example that they have on the repo. I was looking for something with enough kind of complicated kind of setup just to prove the point that manifests work nicely. If you open any of these files, you can pretty much see the configuration of how to recreate that kind of specific component. The information, the bit I wanted to talk about is this application sock shop. It's a way to basically define common variables that you want to apply to all these components at once. So now if you go in the inventory classes application shop that you see right there.
Sorry, application sock shop, yep.
Yeah, that's the one. Yeah. So you can see that from this kind of application, we've obviously called in all the different components, but we also define some default behavior at the end. If you scroll to the bottom, so we define some defaults that we want to apply to all those components that match the same application class at once, which is yet another way to define kind of a characteristic that you want to be applied to all your components at once that you're generating. So in the case that you went before for changing the timeout, if you change the timeout with this kind of if you basically make all your component belongs to an application, or even if you just change the generator default timeout version, you can then apply that timeout to all your components at once without having to go through Echo Server, MySQL, Nginx, and so on. So I think that's another important aspect, the fact that the generator has different level of kind of defaults. You can override that as well.
Excellent. All right.
And I think that's it for me.
Yeah, we covered an awful lot actually there. I'm really happy with how much we've gotten through there, and we never broke a single compile. So that was pretty successful, I'll say. I want to just say thank you both of you for joining me today. I think it was really good to go through Kapitan from start to finish. I think we covered all of the major vocabulary that people need to be familiar with. We broke down the generators and what they're useful for and how they work, and just really showed a really great way for interacting and working with Kubernetes clusters. So again, thank you both for joining me. That was really good fun. Anything you want to say before we finish up? I know that you want to encourage contributions. So, the repository is at github.com/ someone help me out there.
Yeah, sure. So yeah. You, me?
You got to come. Sorry, my internet.
Yeah, good luck's running out there, Alessandro. So I'll let Ricardo give some details there.
Yeah, sure. So yeah, if you want to contribute, and you should, there's no reason why you shouldn't, you can go to github.com/capicorp/Kapitan. Capicorp with a K, so it's like Kapitan. There's many bugs, there's many ideas. There's a lot of people actually helping out in this really fun community. We're also on Slack, the Kubernetes Slack, under #Kapitan.
Oh crap! I don't think I'm in there. I'm going to have to get in there. All right. All right. Again, thank you very much. That was great. Really great project. Everyone should definitely check it out. I think they'll get a lot of value from adopting Kapitan. Have a great day. I'll speak to you both soon.
Thank you.
Thanks.
Thank you, David. Thank you.